Hello friends, my name is Manushri Horkar, grade 9th. Today's subject is chemistry, lesson number 4, atomic structure and chemical bonding. Democritus, an ancient Greek philosopher, studied the nature of matter and basic constituents of all substances. John Dalton in 1808 proposed a theory of atom known as the atomic theory. John Dalton's original theory has undergone modifications, but the principal aspects of the theory are still held valid and useful in the study of chemistry. Now we will see postulates of Dalton's atomic theory. First, matter consists of small indivisible particles called atoms. Second, atoms are neither created nor destroyed. Third, atoms of the same element are alike in every aspect and differ from atoms of all other elements. Fourth, atoms combine with other atoms in simple whole number ratios, forming compound atoms or molecules. Fifth, an atom is the smallest unit of matter which takes part in the chemical reaction, and all chemical changes result from separation or combination of atoms. The modern atomic theory, however, correlates with the Dalton's atomic theory in the fact that the atoms are the smallest unit of matter taking part in a chemical reaction, and in a given compound, the relative number and kind of atoms is a constant. Now we will see discovery of electrons. English physicist William Crookes in 1878 discovered cathode rays. William Crookes found that when an electric discharge is passed through a tube containing a gas at low pressure, blue rays were emitted from the negative plate. These rays were called cathode rays. Sir J.J. Thomson in 1897 studied the characteristics and constituents of cathode rays. He found that the cathode rays had the characteristics. Those characteristics are: first, travel in straight line from cathode to anode and cast a shadow of the object placed in their path. Second, they are deflected by magnetic and electric field. Third, they have a kinetic energy and raise the temperature of the metallic object on which they fall. Now let's see conclusion. First, cathode rays consist of negatively charged particles, now called electrons. Now second, atoms of all types contain same particle electrons and irrespective of how electrons are emitted, they are all identical. Since atoms are electrically neutral, it must contain some particles of positively charged. This leads to the discovery of protons. Now let's see discovery of protons. Scientist Goldstein discovered positive rays emitted from anode, consisting of positively charged particles, protons. If a perforated disc is used as a cathode, positive rays might be seen traveling in a direction opposite to the cathode rays. Conclusion: positive rays consist of positively charged particles, which leads to the discovery of protons. Now let's see discovery of atomic nucleus. Scientist Lord Rutherford in 1911 studied about the atomic model and discovered atomic nucleus. He directed alpha particles towards a metallic sheet. Alpha particles source of alpha particles, radium. metallic sheet of gold foil a millionth of a centimeter. Alpha particles are positively charged helium atoms helium atoms containing 2 protons and 2 neutrons. Now we will see postulates of Rutherford's atomic model. First, matter in an atom is located in the space in the center called nucleus, which is associated with all the positive charge of the atom while remaining volume being a large empty space. Second, since the atom is neutral, sufficient number of electrons must surround the nucleus to counterbalance the positive charge and revolve around the nucleus with great velocity to confer the stability of the nuclear model of the atom. Now we will see the drawbacks of Rutherford's atomic model. First, in Rutherford's atomic model of the atom, electrons revolve around the nucleus and uh, the attractive force of the positively charged nucleus uh, would be balanced by the centrifugal force arising due to the rotation of the electrons. Second, if an electron moves around the nucleus, it must radiate out energy and gradually moves towards the nucleus following a spiral path, and it must until it collide and collapses in it. Third, thus Rutherford's model could not explain correctly the stability of an atom. Now let's see postulates of Bohr's atomic theory. First, electrons revolve around the nucleus in fixed orbits. Each orbit is associated with a certain amount of energy, hence named energy levels. Now second, the integer n represents various energy levels. 1, 2, 3 starting from the innermost. The levels are also designated as KLMN. Third, as long as electron rotates in one of the energy levels, it neither loses or absorbs energy. When energy is supplied initially to the atom, an electron moves to an orbit of higher energy. When this electron drops back to its original orbit, energy is radiated by the atom. Bohr's model gave the preciseness of location and mode of rotation of electrons around the nucleus. Now let's see discovery of neutrons. Scientist James Chadwick in 1932 he established that an atom consists of subatomic particles, that is electrons and protons. Electrons have negligible mass, hence the mass of the atom is concentrated in the nucleus. Therefore, the atomic mass should be equal to the mass of the protons. However, in the case of helium, there are 2 protons in its nucleus, and hence the atomic mass should be equal to twice the mass of the protons. Now let's see conclusion. It was therefore proved that in the nucleus of the atom are present particles which possesses no energy, which possesses no charge, but have the mass almost equal to that of the protons. This confirmed the existence of the neutrons, found to be as heavy as protons. Protons and neutrons are together known as nucleons. Now let's see about the atom. An atom is the smallest particle of an element which can take part in a chemical reaction. and is considered as the basic unit of the matter. An element is the pure substance made up of one kind of atom and which have the same atomic number and which cannot be broken down into two or more substances by any physical or chemical means. The atom consists of the following. First, subatomic particles, electrons, protons, and neutrons. The three subatomic particles, which are of great importance in understanding the structure and behavior of the atom, they are electrons, protons, and neutrons. Second, the nucleus. Protons and neutrons are found in the center or in the nucleus of the atom. Third, the orbits. The electrons revolve around the nucleus along imaginary path known as shells, or more accurately orbits or orbitals.